The geometry of circles and solids will be what we're doing this chapter. And we start with the circumference and area of circles. The circumference of a circle is equal to pi multiplied by the diameter, or 2 pi r. So 2 times pi times the radius, because the diameter, so from one side of the circle to the other through the center of the circle, is 2 radii, because the radius is the distance from the center to the edge of the circle. The area of a circle is equal to pi r squared. Now let's find the circumferences of these circles. So we have a radius of 6 meters. Well, we know that circumference is equal to pi d, so pi times diameter, or because we know the diameter is going to be 2 times the radius, that means it's 2 pi r, which means 2 times pi times 6. So 12 pi meters is the exact value. Note, however, that often in everyday calculations, like if you're trying to consider how much ribbon you need to wrap around a tube, telling somebody, oh, I need to buy 12 pi meters of ribbons is not exactly the most useful. So that's why we can put it in a calculator and put an approximation. Of course, depending on the context of the problem, you will have to round up or round down. Like say you want to put a ribbon around the outside. Yeah, of course you're going to round up. In fact, you're going to leave quite a bit of extra slack so that you can actually tie the ribbon. But that's for application. Here we're not told to round to the nearest whatever, so we're not going to round. We would leave it at the exact value. Alright, let's say we have a circle where the diameter is 5 centimeters. Well, we know that the circumference is equal to pi d, so that's going to be pi times 5 centimeters, so 5 pi centimeters. Now how about example 3? Find the area of the circle, use 3.14 for pi, and round to the nearest tenth. Well, the area is equal to pi r squared. So 3.14 times r. The radius is half the diameter, so it's going to be 4 squared. And you're going to end up with times 3.14. Put it directly into your calculator with whatever approximation they tell you to use. Because if you press the pi button on your calculator, assuming that your calculator has a pi button, you will end up with a rather more exact value than you're supposed to. And you might end up with the rounding that you perform not matching up to the rounding you are supposed to have. Here it's 50.24. Rounded to the nearest tenth, that's approximately 50.2. And the units were meters squared and here meters squared. Let's do some exercises. Find the circumference and area of the circle. Use 3.14 for pi and round to the nearest tenth. Well, circumference is equal to pi d. Now it says use 3.14 for pi, so there we go. And diameter is 1. So we get equals 3.14 or approximately 3.1 meters. And area is equal to pi r squared. So that means 3.14 times r squared. R is 0.5 squared. So times 3.14 equals 0.785 meters squared, which rounded to the nearest tenth is approximately 0.8 meters squared. Okay, then, let's say we have a diameter of 6.3 meters. Well, circumference is equal to pi d, which is going to be 3.14 times diameter, which is 6.3. So 3.14 times 6.3 equals 19.782 meters. Which is approximately 19.8 meters. What about the area? Well, we got area equals pi r squared, which is going to be 3.14 times, we can write 6.3 over 2 because, well, 6.3 is the diameter, and squared. So we put that into our calculator. It's 3.15 squared times 3.14. We're going to end up with 31.15665, but we can just put it down as approximately 31.2 meters squared. Let's say we have a radius instead of a diameter. What can we do? Well, the circumference is 2 times pi times radius. Or rather, pi times double the radius, because the diameter is double the radius. So c equals 2 pi r. The radius is 8.2 millimeters. So 2 times, we're told to use 3.14 for pi. R is 8.2 millimeters. So it's equal to 6.28 times 8.2. 51.496. So it's approximately 51.5. Now the area is just pi r squared, as usual. Pi r squared is going to be, we're told to use 3.14 for pi, so we do that, and r is just 8.2 millimeters squared. That gives us 8.2 squared times 3.14, and you get 211.1336. So that's approximately 211.1. The units are millimeters squared for area and millimeters for circumference, because here the radius we were given was in millimeters, and pi is unitless. There is no unit for pi. It's the ratio of the circumference of any circles to the diameter of that circle. And then people discovered, hey, it also contributes to the area. Ooh, what a coincidence. So the diameter is 15 inches. Well, circumference is equal to pi d. So 3.14 times 15 inches is going to give us 3.14 times 15, 47.1 inches. It's not approximated, because we're rounding to the nearest tenth, but this is already to the tenth. Like there's no additional decimal places. So area is pi r squared. So 3.14 times 15 over 2, or 7.5 squared. So 7.5 squared times 3.14. We run that through the calculator and we get 176.625. 176.6 approximately. What are the units? Oh, they are inches squared, or square inches, because the measurement we were given was in inches. Now for the obligatory problem-solving section, solve a simpler problem. In other words, do your problems in manageable pieces. Like say you have gift cards in packages of 12 and envelopes in packages of 15, and you must mail out 300 cards. How many packages of each should be purchased? Yeah, if you go for lowest common multiple and do this problem, you are grossly overthinking it, so don't do that. Don't overthink problems too much. In this case, you just do it, okay, so 300 cards divided by 12 is equal to, well, okay, 300 divided by 12, what's 12? 12 is 3 times 4. So 300 divided by 3 and then divided by 4. That leaves us 100 divided by 4 is 25 packs of cards. And envelopes, 300 divided by 15 equals 20 packs of envelopes. And that's it. Like, don't overthink your problems. Sometimes, well, very often, they are doable in sections. Now let's say we have this figure below and we need to count the number of triangles of any size. If you're going to count them one by one, you are going to have a serious problem, so you should do this systematically. Break it down into parts. So how many do we have that are 1 and pointing upward? Oh, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, how many do we have with side lengths of 2? Like, say each one of these is 1, so 2 would be this chunk, or this chunk, or this chunk. Well, you can think of it as, what about the tip? Where does the tip rest? What's the top triangle? That's going to be this one, this one, this one, this one, this one, or this one. It can't be any of these ones on the bottom. So that gives us 6. 3. So side length of 3. There's 3 options. And side length of 4. There's only 1. The whole thing. But what about your downward pointing triangles? Downward with side length 1, you have 6. And downward with side length 2, you have just the one in the middle. 1. So total is equal to 10 plus 6 plus 3 plus 1 plus 6 plus 1. So that's 20, because 6 plus 3 plus 1 is another 10. And 6 plus 1 is 7, so that's 27 in total. Triangles of any size in this figure. So you can do things stepwise, or you can do things systematically, and these make problems simpler. Although if you can do it stepwise, it's usually not that bad to begin with. On the other hand, systematic problems can sometimes start off pretty complicated. Okay, so let's say we have hot dogs. They come in packages of 10 and buns come in packages of 8. How many packages of each will be needed to provide 440 hot dogs for a street fair? 440 divided by 10 is equal to 44 packs of hot dogs. And 440 divided by 8 is equal to 55 packs of buns. So yeah, don't try to do everything at once. That tends to go poorly. Mark can plant 3 tree saplings in an hour, and Randy can plant 5 tree saplings in an hour. Working together, how long will it take them to plant 80 tree saplings? By the way, the leading cause of death of urban trees is being planted too deep. The top of the roots should show above the ground, the top of the topmost roots. If you bury the base of the stem in soil, that provides many opportunities for soil pathogens to invade the plant, and it will kill the plant, usually. Also, another leading cause of death is the root ball. When you plant it, you need to trim off any roots that, because of the pots that trees usually get started in, any roots that are growing curved around the rest, that will end up strangling the tree as it grows larger. So you need to cut off those roots that are doing that. All the roots, when you're planting the tree, should be radiating outward. They should be pointed outward. Yes, you may end up cutting off a lot of the roots, which means that for the first few weeks after you plant the tree, you should water it frequently. Not water it too much, but water it frequently, so that the roots can both get enough oxygen and can collect enough water for the plant despite the damage that was inflicted in the short term. So yeah, Mark can plant 3 tree saplings in an hour. Not sure if this is because he's more careful about it and does the trimming as I said and makes sure to not bury it too deep. But hey, it's kind of hard to bury it too deep if you're digging holes really quick. You tend to bury them relatively shallow, which is actually okay for trees. As long as it's not so shallow that it just falls over. Yeah. So how long will it take them to plant 80 tree saplings? Well, both together equals 3 plus 5 equals 8 per hour. Okay, so 80 saplings divided by 8 is equal to 10 hours. 80 saplings divided by 8 saplings per hour. The units work out because that's equal to multiplying by 1 hour over 8 saplings, and the saplings cancel each other out. Units are important business, particularly later when you're doing physics or chemistry. A restaurant has 18 square tables that can be pushed together to form one long table for large parties. Each square table can seat 2 people per side, so you can think of it like this. 2, 2, 2, and 2. How many people can be seated at the combined table? Well, what happens if you add another table? Well, you have the same pairs of people at the ends, and you have 2 and 2, and now you added 4 seats. So, each table added to chain only adds 4 seats. First table had 8 seats. Because you can think of it as sliding this side of the table out and just adding space for 2 more people on each side. Seats. So, we're looking at, wait, how many tables were there? Remember to frequently refer back to the problem. Important business. So 18 square tables. 18 tables means 4 plus 18 times 4 seats, which is equal to 4 plus 18 times 4. If you're doing this by mental math, you want this to be 19 times 4. And you can do that because you can factor out the 4. And then you got 4 times 1 plus 18. Okay, what's 19 times 4? Oh, it's 20 times 4 minus 4. So that's 80 minus 4, which is 76. But of course, you could also, because 18 times 4 is not actually a hard multiplication. Why? Because 18 to 36 and then to 72 is a very common multiplication when you're, say, drilling for math. So there are 76 seats. And your answer is 76 people can be served at this table. 6 people can be served at this table. On the other hand, with your 18 tables and 8 seats per table, you could have served 144 people. Yeah, so large parties, well, why don't we have a bunch of people just sitting at their own tables? You can always turn around and talk. To find the area of a complex figure, you separate the figure into shapes that you know how to find the area of, and then you find the total of these parts. Now you find the area of this complex figure. We got a trapezoid. We know that these sides are parallel, and therefore it's a trapezoid because this is 90 degrees, that's 90 degrees. They are both perpendicular to the same line. Therefore, they must be parallel. At least in 2 dimensions, that's how it works. So, we got area equals 1/2 base 1 plus base 2 times height. This could have gone just over the half part, but oh well. And then you add this semicircle, which is 1/2 pi r squared. So we're looking at 1/2 8 plus 10 times 12 plus 1/2 pi r squared. The diameter here is 10. Therefore, the radius must be 5 squared. Hey, it doesn't say approximate. There's no round to whatever, which means we're going to be giving this as an exact value. So we got 9, because of the over 2 part, times 12, which gives us 108, plus 5 squared is 25. 25 over 2 pi. And this area is in what units? Oh, these are all in meters, so it's in meters squared. Of course, if you tell somebody that a park has an area of 108 plus 25 over 2 pi meters squared, that's not a very useful number, so that's why approximations are a thing. But it doesn't tell us to approximate, so we're not going to. Exercises. Find the area of each figure. Use 3.14 for pi. Round to the nearest tenth if necessary. Oh, so now we're approximating. Okay, then. This is a parallelogram plus a semicircle. So the area of the parallelogram is base times height plus 1/2 pi r squared. Base times height, base is 10 centimeters, height is 5, and then 1/2 pi is 3.14, and r squared, the radius here is half of 10 centimeters, so 5 squared, which is equal to 50 plus 1/2 times 3.14 is 1.57, and that's multiplied by 25. So 25 by 1.57 plus 50. So 89.25. So it's approximately 89.3. That's the nearest tenth. What are the units? Well, this was in centimeters, this was in centimeters. So all the measures we used were in centimeters. We're looking for centimeters squared. If you have to convert between units, like say there was something like 0.3 meters and 20 centimeters, make sure you convert your units to be the same and then use the appropriate units, or units squared as the case may be, for your result. I mean, if you follow the units throughout the calculation, you will arrive at a consistent conclusion. But please don't give us the units are meters by centimeters. No. You use meter squared or use centimeter squared. So 18 centimeters. Now we know that all 5 sides here are equal. What does this imply for the shape? Here we have these 2 sides being parallel, and they're at right angles to this side, which tells us that this is going to be a square, and that one is an equilateral triangle. So the area is equal to side length squared plus 1/2 base times height. Now, because we know that half of this is 9, and this is 18 centimeters. This is also in centimeters. This height will be 9 square root 3 centimeters. Okay then. S squared is going to be 18 centimeters squared plus 1/2 base times height. 1/2 base is 18 times height is 9 square root 3. So you're dealing with 18 squared is 324 plus 81 root 3, because 1/2 by 18 is 9, 9 times 9 is 81. Okay, this is in centimeters squared, but this is the exact value. We don't want that. We want round to the nearest tenth if necessary. So root 3 times 81 plus recall 1, 464.3 centimeters squared. So let's say we have this shape here. It's a rectangle minus a semicircle. So the area is length times width minus 1/2 pi r squared. So length is 30 centimeters, width is 15 centimeters. 30 by 15 minus 1/2 pi is 3.14. And the radius here is half of 15, or 7.5 squared. So 15 times 30 is 45, well, 450 in this case, minus, yeah, you know what? No, 1.57 times that 7.5 squared is equal to 88.3125. Yeah, we're just going to write it out, which is approximately plus 450, 361.7 centimeters squared. Okay. Well, what next? Oh, we have words. Well, what's the area of a figure formed using a triangle with a base of 6 meters and a height of 11 meters, and a parallelogram with a base of 6 meters and a height of 11 meters? It doesn't tell us how these shapes are put together. That doesn't matter, because we have all the measurements we need to calculate the areas, and then add them together to make an overall area, right? Well, actually, we can start off by adding them. So the area of the triangle is 1/2 base times height, and then plus the area of the parallelogram, which is base times height. 1/2 base times height is going to be 1/2 6 times height of 11 plus base times height, that's 6 times 11. So we're looking at 66, and 1/2 times 6, which is 3, times 11 is 33. So that's 99. What are the units? Oh, everything is in meters. Okay, it's in meters squared per area. Now, what is the area of a figure formed using a semicircle with a diameter of 10 meters and a square with sides of a length of 3 meters? What is this, a mushroom? Because semicircle, square. Well, whatever. So it doesn't matter what this figure is. We just gotta find the area. Area is equal to semicircle, therefore 1/2 pi r squared. And square, that means s squared. So 1/2 times 3.14 for pi, as we were instructed earlier for this whole section exercises. Radius, the diameter is 10 meters. Therefore, the radius is 5 meters. So 5 squared plus the side length of the square is 3 meters squared. So that leaves us with 1.57 times 25. So 39.25 plus 3 squared, so plus 9. So yeah, 48.25 meters squared. What happens when we deal with three-dimensional figures? Like, I don't know, a brick? Yeah, that's kind of important considering the world we interact with is not exactly as flat as two-dimensional figures can portray accurately. So, let's say we have three-dimensional figures with flat surfaces that are polygons. What do we call this? We call this a polyhedron. Most rocks are not polyhedrons because they are irregularly shaped. If you have flat faces, on the other hand, you can say that, say, a brick can be considered approximately a polyhedron. It is approximately a rectangular-based prism. In practice, though, if you've ever seen a brick in real life, no. And I'm not even talking about the types of bricks that have holes through them, okay? Those are really complex. A prism is a polyhedron with two parallel congruent faces called bases. A pyramid is a polyhedron that has one base that is a polygon and faces that are triangles converging at a vertex. To be fair though, all these other points are also vertices. It's just the vertex of a pyramid refers to a very specific vertex. If you're using the term the vertex. Okay, so prisms and pyramids are named by the shapes of their bases. For example, let's identify this solid. Name the number and shapes of the faces. It could be a square-based pyramid, but to be safe, it's a rectangular-based, or depending on grammar where you live, it could be just rectangle-based or rectangular pyramid. Pyramid. There are 4 triangular faces and 1 rectangular face. The number of edges, there are 4 edges on the base and 4 edges leading up to the vertex. So 8 edges with 5 vertices. Okay then, let's say we have exercises to identify each solid. Name the number and shapes of the faces, then name the number of edges and vertices. Identify each solid. This is a triangle-based prism, or more often, just triangular prism. Prism. You name the number and shapes of the faces. 2 triangular and 3 rectangular faces. And the number of edges and vertices. 3 edges on each base and 3 edges connecting the bases, so forming the sides. You're looking at 9 edges and 6 vertices. Now this could be supposed to be a square, but to be safe, it's a rectangular prism. Rectangular prism. Okay, then we got 1, 2, 3, 4 lateral sides and 2 bases, all of which are rectangles. So 6 rectangular faces. There are how many edges? There are 4 edges for each base, and then 4 edges connecting them. So 12 edges. And 1, 2, 3, 4, 1, 2, 3, 4. So 8 vertices. Here you have a pyramid. It is a triangle-based pyramid or a triangular pyramid. Triangular pyramid. And it has 1, 2, 3, and 4 triangular faces. For faces. And you have how many edges? You have 3 edges on the base and 3 edges leading up to the vertex, so you have 6 edges. And you have 4 vertices. Now let's say we're supposed to draw and label the top, front, and side views of the 3-dimensional drawing at the right. Well, I pre-drew the drawings. From the front, this isometric grid paper shows us that it's 5 units wide, then dropping 1 unit at each of these stages from each side. And the first stage is 3 units tall, the second is 2 units, the third is 2 units again. So 3 units, 2 units, and 2 units. And it is 5 units wide. Okay, so this is the front view. And from the side, you got 3 units, 2 units, 2 units, and it's 1 unit wide. So it's 3, 2, 2, and 1 unit wide. Okay, this is the side view. And top view. The top, you have the middle protruding more, and then you have distinct divisions here and here from the top view, and it's 5 wide and 1 deep, so 5 by 1. This is the top view. Isometric grid paper is something you probably used before to draw diagrams. So you've probably done this sort of thing before. Just a reminder that you're still expected to be capable of it. Now the volume of any prism or cylinder is the area of the base times the height. For example, let's find the volume of this rectangular prism. So volume for rectangular prisms is length times width times height, right? But what is a length times width? Oh, that's just the area of the base. And then you multiply by the height to find the volume. So, length is 11, width is 4, and height is 5. So you're looking at 11 times 4 times 5, which is 20. So 220. Now the volume is in centimeters cubed. Let's say we have a cylinder. Well, a circle can be approximated as an infinite-sided polygon, an infinite-sided regular polygon. So, it's still volume equals base times height. It's just, since the base is a circle, the volume is pi r squared times height, because the base area is pi r squared. Let's find the volume of this cylinder. Use 3.14 for pi and round to the nearest tenth if necessary. So, we have volume equals pi r squared, because that's a base, times the height. So we're looking at 3.14 times radius is 5 centimeters, so 5 squared times height is 11 centimeters. So we're looking at 5 squared times 11 times 3.14, 863.5. What are the units? Oh, it was centimeters squared times centimeters, therefore, of course, it has to be centimeters cubed. Going over that unit calculation in your head is a good way to make sure you didn't forget to convert any units in case the numbers you were given were actually different units. Of course, when it's all given in centimeters, it's a little bit redundant. So, exercises. Find the volume of each solid. Use 3.14 for pi and round to the nearest tenth if necessary. The volume is equal to length times width times height. So 6 times 5 times 11. So that's 30 times 11, or 330. And it's centimeters times centimeters times centimeters, so centimeters cubed. 14 meters diameter and 15 meters height. Well, volume is base area, which is pi r squared, times height. So we're looking at 3.14, because that's what we're using for pi, times r squared. Radius is half of 14, that's 7 squared, times height, which is 15. So 7 squared times 15 times 3.14 gives us 2307.9 meters cubed. Yeah, we aren't using approximation symbols here because we were told to use 3.14 for pi. Important difference there, because rounding, you should never round when you're substituting in, unless you keep a lot more digits than you are going to end up keeping at the end. That's important business, to make sure you don't end up with a cascading rounding error. Now this volume is equal to base area times height. Now that base area is 1/2 base times height of the triangle, which is a base. And the overall height of the polyhedron is 22 meters, the overall height of the triangular prism. So 1/2 base times height, 1/2 times 16 times height, which is 18, times 22. Okay, so we're looking at 16 times 9, which is 144, times 22. 3168. And it's meters cubed. What if we don't have two bases that are just directly translated on a direction perpendicular to either of them? So in other words, what if it's not a prism or a cylinder, and instead we have a pyramid or a cone? Well, it happens to be that the volume of a pyramid is 1/3 base area times height. The volume of a cone, because a circle can be considered an infinite-sided regular polygon, a cone ends up having the same volume formula as a pyramid. It's 1/3 base area times height. Now, find the volume of the square-based pyramid shown. Oh, well, the volume is 1/3 the base area times height. So that's 1/3 base, which is 30, squared. The base area is s squared in this case, if we were to represent it by formulaically. Height is 28 meters. So 1/3 times 30 squared times 28. So in other words, we end up with 300 times 28. So 8400. And that's meters cubed. That's the volume. So example 2, find the volume of the cone. Use 3.14 for pi. Well, the volume is still 1/3 base area times height. And that means 1/3, and we're looking at pi r squared for base area, times the height, which is 15. So 5, 3.14, and then r is 6 centimeters squared, and we end up with 5 times 3.14, it's going to be 15.7, times 6 squared, which is 36, okay, 565.2 centimeters cubed. So this is the volume of the cone. Exercises. Find the volume of each solid. Use 3.14 for pi. Round to the nearest tenth if necessary. Well, this is a cone, as the diagram suggests pretty clearly. Yeah, the square-based pyramid is really the one that needed to be clarified and named. Because, well, it could have been rectangular, right? So find the volume. Cone volume is equal to 1/3 base area times height. So 1/3 pi r squared times the height is 22. So that's 1/3, 3.14 for pi, okay. And r squared, well, diameter is 38 centimeters, so the radius is 19 squared times 22. 3.14 times 19 squared times 22. divided by 3 gives us approximately 8312, round to the nearest tenth, okay, 0.6. And the units are, everything is given in centimeters, so it's going to be in centimeters cubed. Now a square-based pyramid that's 100 meters tall and 150 meters on one of the sides of the base. Volume is equal to 1/3 base area times height, and that's going to be 1/3 of 150 squared times the height of 100. So that's going to be 50 times 150 times 100, or just 5,000 times 150. Yeah, it's going to be 750,000. So what are the units? Well, it's in meters, all the measurements. So this is in meters cubed for the volume. Let's say we have a rectangular base instead of a square one. What happens? Well, we have volume is equal to 1/3 of base area times height. So that's 1/3 of 20 by 15. 20 by 15 by height. If you're not comfortable going straight to this, you can substitute length times width in the middle with 1/3 and the height substituted in already. So you got 10 times 20 by 15. 20 by 15 is 300. And then times 10, 3,000. And these are all in meters, so it's going to be in meters cubed. Okay. A cone with height of 6 meters and diameter 8 meters, that's got a volume of 1/3 base area times height, or 1/3 pi r squared times height. In this case, though, since we wrote it like that already, we might as well just substitute the height in already, especially because it's so convenient with the 1/3. So we get 2 times pi. We were told to use 3.14 for pi, right? Let's check. So check back to the problem whenever you need to. And even sometimes when you don't need to, because you don't know what you might overlook. 3.14 times r, the radius, the diameter is 8 meters, so the radius must be 4. 4 squared. So 4 squared times 2 times 3.14. That's 100.48 meters cubed. Or approximately, because it says to the nearest tenth, 100.5 meters cubed. The surface area of prisms and cylinders, you basically just add all the areas of the faces together. But how do you find the area of, say, the lateral face of a cylinder? Well, you know that if you unroll the cylinder, like say you cut open a toilet paper roll, you end up with a rectangle. What's the length of that rectangle? I mean, you know the width is equal to the height of the cylinder, as shown down here. But the length is the perimeter of the base. The same applies for a rectangular prism, a triangular prism, whatever. Prisms, you can find the area of the bases and then the lateral area is the perimeter of the base multiplied by the height, because the lateral face is made of rectangles that have a combined length equal to the perimeter of the base, and their width is the height. So we can say that the total surface area S is equal to the lateral surface area L, lowercase l, plus the area of the two bases, 2b. So find the lateral and total surface areas of the rectangular prism. Well, lateral surface area is equal to the perimeter of the base times the height. So, perimeter of base is 2 times 4 plus 11. That's the perimeter of the base, because I chose the top and bottom sides as the base is. And the height is 5. So, 2 times 4 plus 11 gives us 2 times 15, which is 30. So 30 times 5 is then 150. What's the units? Oh, these are all in centimeters, so it's in centimeters squared. That is the lateral surface area of this rectangular prism. Remember, the perimeter is 2 length plus 2 width, or 2 times, in brackets, length plus width. So, the total surface area, S, is equal to the lateral surface area plus the two bases. So, the lateral is 150 plus 2 bases, 2 times the base is 4 times 11. So 150 plus 88, which is equal to 238. And the units, centimeters squared. Okay then, a cylinder, you have pi r squared times 2 because you have 2 bases. And then the lateral area is the perimeter of the base, so 2 pi r multiplied by the height, 2 pi r h. So let's find this surface area of the cylinder. Round to the nearest tenth. It doesn't tell us use 3.14 for pi. That's convenient. That means we can use the pi button on our calculators. So, this is gonna be 7 meters height and 5 meters radius. So, surface area is equal to 2 pi r squared. I'm used to this format, by the way. So, I'm used to this version, which puts the two bases first and then the lateral area. This is going to be 2 pi r squared, that means 5 squared, plus 2 pi, r is 5, h is 7, so 2 times 25 is 50 pi, plus 2 times 5 times 7 is going to be 10 times 7, or 70 pi, which equals 120 pi. And this is the point at which we actually take out our calculators and multiply and round to the nearest tenth. Oh, it's 376.99, guys. So rounding to the nearest tenth pushes up 377.0. And what are the units? Oh, everything's given in meters. So for surface area, we're going to end up with meters squared. Okay, let's do some exercises. Find the lateral and total surface areas of each solid. Use 3.14 for pi and round to the nearest tenth if necessary. Okay then. Lateral is equal to perimeter of base times height. So the perimeter of the base is 2 times 5 plus 6. And then multiplied by the height, which is 11. So 2 times 5 plus 6 is 22 times 11. 242 is the result, and that's in centimeters squared. Now the total surface area is S equals 2b plus L. So that means 2 times 5 times 6 plus 242, which is 2 times 5 is 10, times 6 is 60, plus 242. So 302 centimeters squared. Right. How about this cylinder? Oh, we're supposed to use 3.14 for pi. Okay, so the lateral, we know that it's the perimeter of the base, in other words, 2 pi r, times the height. So 2 times 3.14, and the radius is 8 centimeters, so 8, times the height, which is 15 centimeters. Okay then, 2 times 3.14 times 8 times 15. We can go with 8 times 30, and then times 3.14, and we get 753.6 centimeters squared. The area is equal to 2b plus L. 2 times the base, 2b, the base is pi r squared, plus L, which is 753.6. So it's 2 times 3.14 times the radius, which is 8 squared, plus your lateral area, so the rectangle that wraps around the cylinder. So store this away, and 64 times 2, oh wait, no, I could have just done 128 straight off, 3.14, that's 401.92 plus, you know what, we should write this down, plus 753.6. Which is going to end up approximately 1155.5 centimeters squared. So, this is to the nearest tenth, as specified. Now, how about this rectangular prism? Yeah, totally not deceptive looking, guys. I mean, it totally looks to me like a cube, if not for the measurements being specified. So yeah, remember, diagrams should not be considered to be to scale unless specified. If it looks equilateral, don't assume it is unless specified or unless you can mathematically derive that it is. So here, the lateral area is equal to perimeter times height. So the perimeter is 2 times 6 plus 7 times the height, which is 8. 6 plus 7 is 13 times 2. Well, that's 26. And then times 8. 2, 6 times 8. Not to be confused with the object 268. So this is 208, and it's centimeters squared. Right. What's the total surface area? Surface is equal to 2b plus L. So 2 times the base is length times width, which is going to be 6 times 7. Plus L is the lateral. So 2 times 6 times 7. 6 times 7 is 42. Times 2 is going to be 84. Plus 208. Notice I didn't substitute in the lateral until now, this time, so as to give a comparison of why, in this sort of case, you should probably consider only substituting in when you need it. Because otherwise, yeah, it's a bit more writing for no good reason. So 84 plus 208 would give us 292. And the units are, oh, everything's in centimeters, so this is going to be in centimeters squared. What happens if our sides are not nice and rectangular, or in this case of a cylinder, a rectangle that's been curved around to fit? What if we have to find the surface area of a pyramid? Well, if you have the height of a pyramid from the vertex down to the midpoint of the base, i.e. it's a regular pyramid where the vertex is directly above the midpoint of the base, you can find your slant heights. This is called a slant height. It's the height of the triangle that makes up a face. Now the slant heights may be the same if the base is a regular polygon, like say a square or an equilateral triangle, or they could be different. You can use Pythagorean theorem between this distance from the edge to the center, the middle of the edge to the center of the base, and the height. You can use those to find your slant height. Or you can use half of the edge length here and this edge length to find the slant height using Pythagorean theorem. So you find the lateral and total surface areas of this square-based pyramid. The lateral surface area is equal to, we know it's a square-based pyramid. Therefore, in this case, it's 4 times 1/2 base times height, because we have the height of the triangles. In other words, the slant height already, and we have the base, which is the side length of the square base. So it's 4 times 1/2. I mean, we could have changed this to 2 if we liked, but, well. Base is 20. Height, the slant height here is 30. So what do we got here? Oh, we got 40. Like these things all put together. This is 10, this is 4. So 40 times 30. And that gives us 1,200 meters squared. And the total surface area is equal to the base area, because there's only one base in a pyramid, unlike a prism, plus the lateral area. The base here is 20 squared, plus the lateral area, which is 1200. This is equal to 400 plus 1200, so 1600. Okay then. Exercises. Find the surface area of each square-based pyramid. Round to the nearest tenth if necessary. Find the surface area. Well, here we have the slant height already. These are all square-based pyramids. Okay, good. We don't need to calculate off of multiple slant heights. So, surface area is equal to base area plus lateral area. So 30 squared plus 4 times 1/2 base times height, because we have 4 identical triangles. You might have noticed something interesting here. This figure, if it was drawn to scale, it would look like a needle, because this slant height is 50 meters, while the base length is 30 centimeters. So 50 meters is 5,000 centimeters. Yeah, base, okay, 30, but then we have a 5,000. Fun times. There's 900 plus 2 times 5,000, so 10,000 times 30, so 300,000. Yeah, this is 300,900 centimeters squared. That is the surface area of this square-based pyramid. Right, here we have one that has a 50-meter edge and a 60-meter base side length. What does that mean in terms of Pythagorean theorem to find the slant height that we need? Slant height is equal to the square root of 50 squared minus half of 60 meters. Oh, that's 30 squared. So in other words, we're going to end up with 40 meters for our slant height, because this is a 3, 4, 5 right triangle. The ratio fits. Now, what happens when we calculate the surface area? Well, that's equal to base area plus the lateral area, which means 60 squared plus the lateral area of, well, it's a square base pyramid, so it's 4 times 1/2 base times height. Base is 60. Height is 50. So you got 3,600. And then 4 times 1/2 is 2. Times 50 is 100. So plus 6,000. Now, that's going to end up being 9,600. And the units, oh, it's meters and meters. So it's meters squared. Yeah. So as you can see, sometimes you can end up with trick questions where the units you are given are not the same units. And other times you might have to find, say, the slant height yourself by using Pythagorean theorem. Similar solids have the same shape, their corresponding linear measures are proportional. So the ratio is the same, like 10 to x is equal to 12 to 8. And their corresponding faces are similar polygons. These cones are similar. Find the height x of the cone. Well, we know that x over 10 is equal to 8 over 12. So x is equal to 80 over 12, which means that we're looking at 20 over 3. Or you can give it as 6 2/3. And it's meters. Alright, these pyramids are similar. Find the total surface area of pyramid A. Linear ratio is 10 to 5, so 2 to 1. But the area, what happens with the area? Oh, you have one dimension, one linear dimension multiplied by the other. One linear dimension, which is twice as much, multiplied by the other. So you have this thing called the square cube law. Square cube law. Area ratio is 2 squared to 1 squared, which is equal to 4 to 1. Because if it's twice as long and twice as wide, the area is how much? It's 4 times as much. And the volume? It's twice as wide, twice as long, and twice as deep, or twice as long, twice as wide, and twice as tall. You have a total of 8 times. So 2 cubed. So it's 4 to 1. The total surface area of pyramid A, so the surface area of A, is therefore equal to 4 times the surface area of B. So 4 times 102 centimeters squared, which gives us 408 centimeters squared. Now let's do some exercises. For exercises 1 and 2, the solids in each pair are similar. Find the surface area of solid B. So, SB over SA is equal to length of B to length of A squared. So D of B over D of A in this case squared. That's going to be 12 over 6 squared. And B, S of B, is over 90 meters squared. So you're looking at S of B is equal to, this is 2 squared, so 4 times 90 equals 360 meters squared. That's what the surface area of B is. Now here we gotta find the surface area of B. Surface area of B over surface area of A is equal to, well, here we only have one linear dimension, so let's call that the base. Base of B over base of A squared. So that's 5 over 10 squared, which is equal to SB over SA is 200. So therefore, the surface area of B is 1/2 squared is 1/4 times 200. So that gives us 50. And it's meters squared is equal to S of B, the surface of B. All right then, let's say we got a linear ratio that we're looking for instead. Kind of weird that this wasn't before the areas and exercises, but oh well. So, x over 12 centimeters, because these are clearly corresponding sides for these similar solids. Yes, I know that I said don't assume that figures are to scale, but they're supposed to be at least vaguely to scale when you're comparing like similar shapes. Like you can say, oh, 10 over 12 is equal to x over 5. No. No. Look, if you were supposed to do that, this would be a troll question, and first of all, there would probably be actual lettering marked out, and then they'd be like, oh, the rectangle, point order, is similar to the rectangle, point order going the other way. That would actually give you a hint that no, this is supposed to be extremely not to scale. So, without such things, you don't assume that they are to scale, but they should be vaguely corresponding. Like you wouldn't draw a clearly obtuse triangle and be like, oh, this is supposed to be equilateral. No, you should at least kind of try to draw it equilateral-ish. So, here we're dealing with x over 12 is equal to 10 over 5. So x is equal to 2 times 12, which gives us 24 centimeters. Yeah, it's just regular algebra and ratios. So 12 centimeters to 4 centimeters is equal to 18 to x. But because we like putting x in the numerator, x over 18 is equal to 4 over 12. So we end up with x is equal to 1/3 of 18, and therefore x is equal to 6 centimeters. Right? We have an issue here, guys. So x is 6 centimeters, but this is in meters. Says meters. Oh, right. Also, when you're comparing things, make sure that you keep an eye that both of these are diameters. For example, this could have been a radius and this the diameter, or vice versa. And that would also have been a trap for people who aren't paying enough attention. So because it says meters, 6 centimeters is equal to 0.06 meters. So x is equal to 0.06 meters. I mean, technically x is actually unitless because it says x meters there. So it should be x equals 0.06, but I'm just making everything very, very clear, okay? Well, that's it for this chapter. So, see you next chapter.